cryptographic task for today. So, I'm Nick from the defense community. And I want to discuss with you guys today what we can do and how we can use cryptography. So it's a subtopic which potentially is of interest to you. And maybe some of you want to, develop a career in this field. Let me start by explaining why I'm a big fan myself. This country has given birth to lots and lots of eggheads who sit in the cellar and code away. This is our superpower, the real one. So I would love us all to discuss how we can actually use this superpower to make more money. I want to invite here Alexei Kurchkin from SBER. That's your chair.
Черный. Алексей Карасев, преподаватель...
So it's black. Alexei Karasov from MIPT. Alexei has got some very interesting things he doesn't tell people about, like the protocols he is in charge of and big companies he has been working for. Hundreds of millions of USD do not feel alien to him. It's a privilege to have you on the stage, sir. And certainly we have Rasul Ibragimov. R&D, privacy, and scaling exploitations. So Rasul knows a lot about exploiting it all. So you see, you've got an orange chair and an orange mic. Easy to remember, right? The format will be like this. We'll spend about 40 or 45 minutes chatting about things I hope you will find interesting. Hello there. Hello. Why isn't he talking back to me? There is a child over there. You see, I hope the child will get back to me. So, Alexei Kurchkin, can you please tell us something about yourself?
Всем добрый день.
Hello, everybody.
Где работал? Наверное, криптографии с точки зрения
Now, in terms of cryptography, I've been doing cryptography on the regulator side for several years. I worked for a vendor for several years, and now I'm working for SBER, looking at the development of it all. I also teach at MIPT, blockchain and higher mathematics, and I've been doing it all for pretty much my whole life. So shall we discuss cases later on? What's your alma mater? I'm a graduate of Bauman Institute. Oh, my condolences. What kind of degree did you get there? Was that management? No, that was mathematics. Okay, thank you. Alexei?
Всем привет, меня зовут Алексей.
Hello, everybody. I'm Alexei Karasov.
Достаточно обширный опыт. Начинал
I think my experience is pretty broad as well. I started out in the world of finance. And then I went over to the dark side of IT, and I spent quite a lot of time there. I was a CTO, among other things. And there was a moment when I got exposed to blockchain.
Достаточно интересный стартап в DeFi.
And I launched an interesting startup in DeFi, even if I say so myself. And I'm taking a big interest now in cryptography. And I teach mathematical methods of cryptography at MIPT. And you're a graduate of Moscow State University, mathematics, and also New Economic School. Wow, that's impressive. I'm Rasul. I work for Ethereum Foundation. In particular, I'm responsible for privacy and scaling explorations, which is like a cryptography lab. So we do research and development in the field of applied cryptography. We do lots of things related to MPC, SDK. I'm also a graduate of Bauman. The 9th department, whatever that means. Oh, great. Thank you.
Я попрошу ребят. Видите, нам даже больше времени дали, чем до этого. У нас 57 минут. Предыдущая лекция была 50 минут всего. Нас любят здесь. Так вот, Расул, давай мы с тобой продолжим по направлению следующему. А что именно ты сейчас исследуешь по CE.dev, куда лежит взгляд твоего исследования? Что ты исследуешь для себя?
В данное время мы занимаемся, я, собственно, и есть еще несколько человек в команде, мы занимаемся исследованиями в области ZK-ID, то есть это в целом направление, связанное с анонимным использованием разных, я не знаю, криптопротоколов, просто разных приложений. При этом ты можешь логиниться в данные протоколы с вашими просто...
I'm sorry. We seem to have experienced a disruption here.
С вашим Google аккаунтом, с вашим GitHub аккаунтом. Вы можете
So I've been talking here about logging in with your Google or GitHub account. So you can do this or that in a protocol if you prove that you're a holder of a particular account.
И какими
So this is the kind of scenarios we're looking at. And what are your primary interests? It's hard to answer this question, actually. It really depends on the situation.
MPC протоколы. Вот.
We are using some MPC protocols and EZK as well. EZK, I think,
Спасибо. Алексей,
primarily. And MPC for sure. Alexei?
сейчас вот что... Я просто наслышан про B-News.
I've heard a lot about Binius.
Для меня сейчас достаточно интересное направление за КВМ. Оно достаточно...
Yes, ZKV.
Ну, вообще, то есть, может быть, стоит сказать, что такое Zero Knowledge Proofs. Я думаю, это будет...
I should probably remind everybody what zero knowledge proofs are. So zero knowledge proof
Один доказывает результат каких-то вычислений, второй их проверяет.
is a protocol where one person or like one participant proves something and the other validates or checks it. So it has two features. One is privacy. So the prover has got some data they don't disclose. All they disclose is the result of computation.
Масштабируемость, так скажем, то есть
And the second attribute
данного вычисления,
is scalability,
если быть точнее,
because
технически, чем
it is logarithmically easier to check the results of calculations than to perform them.
достаточно сложное.
Realization of such protocols
Есть некое направление, которое
so far has been
делать его легче.
pretty challenging.
Называется ZKVM, то есть это Zero Knowledge.
And ZKVM, or Zero Knowledge Virtual Machines, are designed to make things easier.
Мы это привыкли,
So
например, на
they want to effectively enable us to, come up with software like you would do on Rust, and then you create a framework that will prove that indeed such and such proof is correct.
Вот этот кейс, он
Will validate it effectively.
понятно, все хотят писать простые.
It's a pretty well-known case now because everybody wants to develop simple software,
Большой use case достаточно. Это
and a pretty well-known use case involves real-time proving
к чему как бы
of Ethereum blocks.
делать. Но это открывает
Why would you want to do that? Well,
горизонты, так же как в
that opens up
так и в принципе в каких-то
significant prospects, both in terms of efficiency and in terms of other network use cases.
многим
Now, the problem that Ethereum has, and it's not exclusive to Ethereum, is that every block
много раз. То есть каждая нода, она вычисляется
gets calculated many times by different nodes, so that's obvious duplication.
о том, о чем я сейчас говорил. У них есть свойство, что
High-level redundancy, zero-knowledge protocols are great in terms of, you can actually validate it quickly. So you can compute it once and then validate it quickly with other nodes without wasting the resource.
помимо того, что мы делаем систему в целом более эффективной,
And besides making the whole system more efficient,
бывает такая технология.
it also opens up
Мы можем
some very attractive use cases.
увеличить количество газа,
For example, we can significantly increase the amount of gas inside the block, meaning that you can
все время.
perform many more transactions per block because you don't need to repeat so many computations. And the holy grail there
Между разными чейнами. То есть если
is avoiding liquidity fragmentation between different blockchains because we've got Optimism and Arbitrum and Ethereum and other chains.
средства это там отдельно.
So in order to transfer funds between them, it takes weeks with all the bridges. But here we can bring them all together in the same kind of space,
Он активно
thus bringing all liquidity back to Ethereum. And Vitalik is trying to make it happen.
Алексей у нас потрясающий спикер, который много рассказывал.
Alexei is such a great speaker. I absolutely love listening to him. Please stop me if I get carried away, okay?
Так, но мы в Сбере занимаемся...
Well, at Sber,
Да,
we are looking at threshold mechanisms, and I may actually go off on a tangent here. Okay, so you want to participate in a battle, Alexei versus Alexei, an epic battle. So when I call it a threshold, I mean that when the number of participants who want to participate in a particular computation thing exceeds a certain threshold. So let's imagine that you want to perform a cryptographic transaction, like put a signature. And you set the threshold on your own, right? So if you hit the threshold, this transaction will happen, otherwise it won't. And then you can set this threshold depending on your kind of attacker profile. So for example, you can assume that, okay, I've got a lot of crypto in a particular wallet, and I don't want this particular device to be used for, the proving process. And you can actually give this key away to your friends or whatever, and when the number of friends devices who confirm the transaction exceeds a particular threshold, only then the transaction will actually happen. So this threshold cryptography is considered a new paradigm. So we have the classic mathematical attack, so we had like a previous presentation about it. But in many cases in real life, we will be seeing both cryptographic and technical attacks. So the Museum of Cryptography had this podcast. I don't remember the name of that episode about the profession of cryptographers. So a member of the museum talked about a particular encryption method. Said, well, you have this sort of one-time kind of password where the length of the key is the same as the length of the text, and it's difficult to crack it. You may remember a person named Andreev who worked, for the authorities, and you can even read his discrete mathematics publications. So he described this case where the U.S. Embassy used one-time gamma to encrypt their top secret communications. So you may be thinking that with, a one-off gamma, you cannot really crack it. But it's not really the case because, and I'm trying to give you the short of it, but, when they sort of added one and one, when effectively our spectrogram showed spikes, and these spikes would correspond to, say, 1 + 1, and you know that the text is in English, and, the rest can be deduced if you know your tricks. So you can also factor in the time of execution, and then people can make mistakes in the code, and there can be memory leaks. I was also planning to listen to this report about attacks versus the operating memory. You can also have, this algo run very well in one operating system and not the other, and be working well with a particular library but not the others. So it's impossible to consider all these cases. That's why the new paradigm is like this, where you say, I'm not going to be using just a single device for encryption. In fact, you can use the same device, but then you sort of split it. And then the attacker will potentially attack one key, maybe two keys. So you can set a threshold high enough to make it non-feasible to attack it. So we would love to help this sort of thresholds part of everyday life. So, for example, I'm thinking of a grandmother who can, split her password between her grandkids. And I'm also thinking of doing it for the jobs, right?
Вот ты рассказывал с точки зрения, если мы углубимся в то направление, по тому, что ты делаешь, про
Now, if we talk more about what it is that you're actually doing, about optimal and suboptimal paths, I think that, multi-sigs are sort of a legacy thing now. Is this correct? No, this is not a multi-sig. No, these are not multi-sigs. These are thresholds I'm talking about. I remember it's Frost in 2024. So together with MIBT students, we developed an attack chain, so to speak. And there is a SIT algorithm post-bundle, and all cryptographers say it's great. And then some mathematician saw it, identified some extraneous parameters there, and he broke it. So there is no post-quantum there. What a horrible mathematician. What's your take on the future of this technology? Let's also discuss use cases. We have developed an ideal use case for a particular encryption system. like this? Well, it's already being used in a GOS key or, governmental key application.
Стандарт,
Any other areas?
когда он может быть легко
If it becomes standardized, when it's easy to implement in different applications, where do you think we're going to see it? In other words, where should we develop the tooling for it right now?
Подпись используется
Everywhere you're using signatures.
self-custody, тот же Coinbase.
An obvious case would be point-based self-custody 2 out of 3, where you have a part of the key and the exchange has another part of the key. This way, and I'm not a big expert on that, but I'm thinking of specific legal aspects of it all. So, for example, they tell you, well, you're not allowed to store,
Ну, и смотря какой пароль,
as a bank, you're not allowed to store crypto assets. Well, then you can share the key and the users will be able to move their crypto around, and then you can do partial approval or whatever.
всего работать
So, well, for Web3, that would primarily mean
с доступом.
dealing with the access rights primarily, not so much even as personal data. Is that what you're trying to say here?
то есть любое это
Wherever SIGs are used.
Не, неправильно, потому что вот товарищи, кого я знаю, ICP, это Internet Computer Protocol, у них threshold,
Now, the people I know, like ICP,
они используют
they released
распределенную
their threshold for encryption, and their point is that this way you can actually
биткоина.
own assets from another chain. So they effectively enable you in their chain to manage blockchains.
Создавать его зеркало.
I'm sorry, bitcoins.
И, по сути, управлять этой штукой, и когда надо прокидывать...
So their chain, I think, is near, but then you can use MPC to establish a threshold for like owning and proving the ownership of Bitcoin. Yeah, you can use threshold signatures like this, I guess. Alexei, what would you like to add about threshold encryption? What would be the use case that you see for it?
Шифрование — это достаточно полезная вещь, когда
Threshold encryption, in my opinion, is a pretty useful kind of thing, particularly when you need to split responsibility between different types of software.
где мы делаем какие-то custody кошельки.
Like in the real world, we will have, say, custodial wallets, and you need several people to be able to sort of validate with their SIGs.
К примеру, есть
But I'm also thinking about
как TEE,
software suites. Now, you do remember what TEE is, Trusted Execution Environment.
который выполняет какую-то практику.
A secure space within a CPU which runs some software, and it can verify that it's effectively doing exactly that and nothing else. Now, if we split a private key
И безопасно
between a non-trusted and a trusted area,
координироваться, чтобы что-то сделать.
naturally they will need to coordinate what they're doing if they want to get things done, but we'll also have an element that's trusted.
Например,
And a good example of such a technology would be ZK-TLS,
сказать, что результат какого-то HTTPS
where we can prove that a result of a particular HTTPS call, that like we have connected to such and such server, and we have indeed received such and such response.
механизм — это, например, Oracle.
And the simplest mechanism is an Ethereum oracle.
Запрос, например, к Binance,
We can effectively make a call to Binance
доказать, что мы действительно
regarding a current price. For example, get a response and then prove that yes, we sent a query to Binance, we got such and such response, and it's indeed coming from Binance.
ну, наверное,
And then use it.
есть целая плеяда таких кейсов, когда,
And I think that there is a plethora of cases like this.
например, приведу,
Let
например,
me give you another example.
и агенты, которых еще как...
Think, for example, about an AI agent. There are not too many out there,
Вот,
but we are promised there will be so many of them.
мне пользователь запрос
So, you may want this AI agent to be able to, say, perform an activity on behalf of a user, say, book a hotel on Booking.
то есть
And you don't want the agent to have the name and the other personal identifiable information on the user.
который делает сам букинг, мы его запаковываем в эту защищенную область,
So the call to booking
вызов оттуда. И, собственно,
can be made from TEE.
таким образом,
And all the decryption will be happening in TEE as well. And we are splitting the keys between TEE and the regular part.
она знает, что в ТЕ только будет...
So the regular part,
Проверила, зазипала.
so it unzips, checks, and zips back again. Yes.
Сервисы букинга
And nobody gets to see this data except for booking.com, which obviously, or another booking service which needs it.
Да. Я
Russell?
добавил
over to you.
Пользу пороговых систем. Как раз-таки вот
First, I want to add something about threshold systems.
ZKID, там даже как раз-таки
In the ZKID field where I work, we absolutely need threshold systems to generate the so-called nullifiers.
что
So what's a nullifier?
я не знаю, Google,
Now imagine you're logging in with your GitHub or Google account,
то, что это именно вы делаете, то,
and
то, что вы совершаете,
to track that it's you doing it
вы никакой след вообще не оставляете. Иногда
is not really possible. You do not leave much of a trace. While in some apps you want some trace to be maintained, like a pseudonym at least. So, for example, when you're doing, say, some anonymous voting for Web2 identities,
вот этих аккаунтов, которые
so you can say, we've got this set of accounts which are allowed to participate in the voting process. Then you log in, you cast your vote,
от того, чтобы зарегистрироваться снова,
and nothing stops you from registering again and voting again,
то есть этот псевдоним
unless you're using a pseudonym.
того же человека,
And this pseudonym
ну, короче, действия одного и того же человека будут
will effectively show that, okay, such and such user has already participated in the voting.
out of the box.
It's pretty difficult to get it in Web 2.0 out of the box. In fact, MPC was developed for that particular reason. So we get several computers together, several nodes, and they will calculate your pseudonym together
Основываясь на
based on your username and nickname. But they don't get to see your nickname.
вместе в совместных вычислениях вычислить
So all together,
как раз-таки
they can do the calculation. So threshold systems are indeed important there.
в протоколах. У нас
And I think this would be true for any MPC protocol, that
с
we can have liveness issues, right?
нам нужно
So
произвести решеринг. Это когда мы генерируем новые
if a node has gone down,
вот,
we'll need to reshare the keys.
пороговые системы. То есть
And this is where threshold systems would be very useful. So I can think of lots and lots of applications.
Системами, которые мы
What are the current limitations
сейчас решать начать.
with regard to existing threshold systems?
ограничения,
Limitations?
ограничения в голове.
I know of none.
Не знаю, может, Алексей может что-то добавить.
Maybe Alex says no.
Я бы, наверное, только сказал, что хочется, чтобы они были постквантовые.
Well, we do want them to be post-quantum. Well, they keep promising quantum computers to us that will screw up all cryptography. So having them post-quantum sounds like a good requirement. US NIST, the standardizing agency in the field of cryptography,
не постквантовые.
states that by 2030,
2035 вообще не будет.
we should deprecate all that's pre-quantum, and we should totally discontinue using everything that's pre-quantum by 2035. Well, let's see if that really happens, but in any case, that's certainly the trend now.
Некоторые протоколы.
I think that some protocols have already standardized signatures,
Думаю, скоро мы.
and I think that as an industry, we are certainly embracing threshold encryption. What's your personal take on the danger of quantum computing?
Слушай, ну я хотел это поисследовать, но вот в моем
I really wanted to explore that,
два лагеря.
but people around me belong to two different camps. Some say it's a real threat, while all the others say these are fairy tales.
Это можно
We
сделать,
should not be concerned.
сделать и жить спокойно, да, как
You know, if it can be done,
квантовый компьютер сделает его. Не...
you know, if we can develop something post-quantum, I hope, I mean, it's better to have it, particularly if you do a cache out before it happens.
Заморачиваться
Alexei, what's your take on that?
криптографию.
Shall we be obsessed now with transition to post-quantum cryptography? I think we should be obsessed with it, but we should not really migrate it, because 2030 is pretty near, pretty close, and I don't think that
Что значит приблизились?
it's going to happen that quickly.
Ну, вот мы тоже с Алексеем обсуждали и с Расулом.
Can you please elaborate? We've been having this discussion with Alexei and Russell. I saw this review that signatures are taking a long time to get calculated. So obviously it's not going to happen, say, for IoT, or they take forever to be validated.
По этому поводу пос-
Russell?
То же самое.
Same.
Про постквантовые что именно? Типа, какие ограничения? Стоит ли в эту сторону?
Are you still asking me about limitations or whether we should be going there? I will agree with the previous speakers. Yes, we should be preparing for that. And I believe what Vitalik said about that. Yes, we should be exploring the remit, so to speak, of post-quantum cryptography, but it's a bit too early for us to start implementing this stuff. I mean, once we research enough, we can start implementing, but I suggest that we first do proper exploration.
Много рассказывал про ZK-ID в целом.
You've been telling us a lot about ZK-ID. Can you please tell us more about the
Ну, то есть, я
the state of the nation, so to speak, in this field?
WEB3 это есть там блокчейн-мир, токены, DeFi.
So Web3 is the world of blockchain and tokens and DeFi.
Такого выходит в реальный мир. Обычно это
And
который в целом
the intersections between Web3 and the real world are limited. Well, it's certainly the digital assets
и что там сейчас происходит в этом направлении.
and not much else, right?
Вообще старый.
I think the problem itself has been around for quite some time. And people have long wanted
Данные WEB3 ID
to bring Web2 ID data to the world of Web3.
без этой приставки, без
Previously,
анонимности, без
it was done without,
делали какие-то. И до сих пор делают какие-то identity.
ZKID. And people are still developing new identity wallets.
WEB2 identity
You can still use your Web2 identity on a blockchain.
криптографии с развитием
But with the development of cryptography,
все больше и больше людей
with the development of
пользоваться.
ZK,
При этом мы
a
все
growing number of people want to use the systems anonymously. And we still want
того, что мы можем доказать, то, что да, мы действительно, я не знаю, там,
to make sure that, we can prove that indeed we own this passport or this Web2 account,
при этом мы не хотим
that this is indeed my biometric data, without at the same time disclosing it to everybody.
развитие этого пошло после того, как начали развиваться протоколы,
I think this development
про которые говорил только
has been spurred
TLS,
by the emergence of protocols like ZK-TLS and similar protocols like
то есть не ML,
ZK,
не machine learning,
ML,
именно ML.
ML, I'm sorry, not machine learning.
Дали новый толчок.
So these protocols, in my opinion, gave an impetus to the development of ZK-ID systems. And another technology that has to be mentioned is Open Passport, which enables you to prove that you are effectively the owner of a biometric passport
Вот, то есть в биометрический паспорт обычно вшит
by proving your SIG.
приватный ключ. Вы можете этим приватным ключом поставить подпись.
So there is usually a private key embedded in a biometric passport.
На вашем
And this way you should be able to prove claims about your data stored in your passport without disclosing this data.
18 лет или там
So, for example, you can prove that you're over 18
вот.
or that you are not coming from a country laboring under sanctions or whatever.
Насколько
So I think that's how we can use ZKID.
будущее данного рынка? То есть мы знаем, есть WorldCoin,
What's your take on the future of this market? So there is Project Y, there is WorldCoin.
данных, технологий.
Is there, much of a market there?
Большой. Мне кажется, рынок очень
I think the market is there, and it's actually a huge market already.
пользования. Вот.
What really matters, however, is convenience.
Каких-либо вот, я не знаю, ZK-ID кошельков, скажем, identity кошельков,
Most ZK-IDs and ZK-ID wallets, I'm sorry, are either not very convenient or not secure enough, like they're not fully trustless.
я не знаю, там ты логинишься со своей какой-нибудь Web2 идентичностью, вот,
Like you log in with your Web2 identity and you have a private key generated for you, and it's effectively stored in a company's server.
тоже вот в TE, то есть
And it's usually done not in the server, obviously, itself. They are usually stored in a trusted enclave, but it's not a proper trustless solution.
делать такие системы
But there are studies being conducted now around making such systems more trustless
третьим сторонам,
so that you don't need to trust third parties.
чем занимаюсь я.
And this is actually something that we are doing, among other things.
Больше как готовый
So
продукт.
you're effectively telling us that you see it as, a ready-to-use product as opposed to tooling.
Должен быть какой-то, наверное,
The way I see it is that
identity walletов,
there should be one or maybe several identity wallets
знаете, своими.
where out of the box,
Ты их можешь
you can log in with your Web2 identities. You can use them on blockchain directly in a trustless way.
вот как-то
and anonymously.
Просто такие продукты есть.
I think there is demand for products like this.
На данный момент либо не trustless, либо
But like I've been saying, the current solutions suffer from not being trustless enough or having poor UX.
Что это имеется в виду? Ты можешь получить там
I realize that
free spin или там какой-то,
you can have, say, a free spin or airdrop or
не пустой, там есть какие-то.
or some other account. If you have, say, GitHub, if you got some commits, it's difficult to talk about that in times of agents, but that's how I heard it.
То есть ты заходишь, ZK-TLS,
Another option is when you have, say, more than $500 in Revolut. So the problem they had was in
верификатор зависел
jobs the subject. Again, the verifier, the validator, depended on the data structure that you use to extract information TLS.
паразитирования на чужих продуктах. То есть какой-то proving.
And that, to me,
Правильно, да?
sounded like, parasiting of somebody else's products.
достаточно много можно разных приложений вообще строить с помощью, я не знаю.
You know what? You can certainly develop lots of different applications using ZK-TLS and ZK-MELS. One of the recent things I saw and I liked, I don't remember the name, I'm sorry about that.
Называется proof of commitment. Вот.
I think it was called proof of commitment or something. So you sort of commit to running 5 kilometers every day, then you stake a certain amount of money. I don't like the idea.
Ты как раз таки provишь, что
And then with ZK-TLS, you're actually proving that you've run it. And if you have not been able to, provide your proof, your stake can be taken by other people.
Комментарий, наверное, добавить. Я на самом деле
Let me add here,
этого кейса
I do believe in the great importance of this case of ZKID. I think it is going to bring the worlds of Web3 and Web2 closer. This way, financial services institutions will be able to offer a proper portfolio of offers, such as deposits and non-collateralized loans.
общая надежда, что там
And Web3, the hope is that in the world of Web3, everything will be more available and more affordable because costs will be lower.
Какие-то.
Any other use cases of ZK-TLS?
на практике я не видел. Это такая
I've not seen them with my own eyes,
но вот
because after all, it's a pretty newfangled thing. But oracles are certainly a good case.
делают. Я конкретный код.
I think some people must be doing them now.
Вот, а так, наверное, что-то еще есть. Но я точно не знаю.
Раз.
And there should be something else.
Да, мне кажется,
Russell?
все-таки важно тоже помнить, что это не
I think it's important to remember that ZK-TLS doesn't necessarily guarantee trustlessness.
эта информация, которая пришла.
In many cases, you have a party that claims that the information coming from the server is correct, meaning that you have to trust this centralized party. You can replace it with an MPC, but there is a degree of trust built into that as well.
Да.
И тогда, в принципе, там...
Yeah, you can build your notary, so to speak, into TEE.
Алексей, твои мысли по этому поводу?
Alexei,
Что мы еще раз? Какой вопрос?
what's the question again?
Изначально, то есть существует
ZKID was the initial discussion. Is there demand for ZKID? What kind of use cases have you seen?
Я с ребятами соглашусь, я не сильно силен в этом.
I will agree with the team here. I don't consider myself an expert on this topic.
Для людей
Remember,
учить криптографию, да?
we wanted to discuss something that would resonate for people who are interested in the world of cryptography right now. I want to bring a lot of flies to this ointment. Like, if you want to jump on this bandwagon,
Разбираться.
you will have to learn so much mathematics.
Плюсы и минус. Вам надо знать
The benefits of cryptography
силу теории вероятности.
or the drawbacks are that they gotta know it all. Theory of numbers and mathematical statistics and so on and so forth. Well, you can see it both as an ointment and in a fly.
делать.
I like how Alexei delivers it.
К тебе, Алексей, вопрос будет. Какие ты видел
To you, Alexei.
То есть как бы просто будущее криптографии само по себе, оно должно
The future of cryptography, in my opinion,
в использовании. То есть когда там
should be all about applications, right? ZKML, for example, is not something dramatically new.
большой возврат нарратива, когда WorldCoin появился. Не
And I remember that, this whole subject was rejuvenated when WorldCoin was launched. And you will remember the problems of that particular project. In fact, it's a global issue of
вашего свойства,
linking a particular attribute
что все биосвойства
to your ID is that all biological attributes change over time.
там
And here we want to have a feature that is like permanent. So even human eyes change color over time.
когда WorldCoin вышел, это было совершенно
So when WorldCoin was released, people were skeptical initially.
фактор, что в идеале этот параметр, который у вас есть, он
Ideally, this parameter
не видит.
has got to stay inside you all the time. Ideally, it should not be visible to an outsider.
Отпечаток можно
Like
там
a fingerprint can be stolen, right?
способом генерации ключа для WorldCoin.
An ideal way of generating a key for WorldCoin would be a QR code on your palette. Something that, is pretty difficult to extract from you unless you want it.
Оно позволяло покрыть
So ZKML
динамических метрик человека
sounded like something
предиктивно терминированным ответом, который позволяет
ambitious because, you could combine something that's biometric with something that's, predictably determinable, so to speak. I think that they decided against it over time because it's difficult to calculate predictions and alphas and deviations. But that was their initial hypothesis. So I think that cryptography is why we're using all that. Now, technologies can be diverse there.
мы должны сейчас
So the question here is like this: where do we need to start going now?
где мы должны ее
Is there a particular area where we need or we can actually
Слушай, в принципе,
change things with cryptography?
вот активно развивается в целом направление общее, про которое мы в основном здесь говорим, которое называется программируемая криптография, да, то есть
Programmable cryptography is developing very fast now.
в основном работа с криптографией это было зашифровать,
Until recently,
при желании расшифровать.
cryptography was about encrypting things and later on, if you need it, decrypting them.
Но тем не менее,
Now, the attitude is that we want to have data encrypted at any point in time while still being open to some handling. So FHE and ZK and MPC,
каждая по-разному, но предоставляет вот этот комплекс
all these kind of concepts, they support this in their own ways.
очевидное применение. Это аналитика, да,
Now, the obvious application is data analytics. In order to perform some analysis now, you need to collect all the data, like PII, then feed it through an engine or something,
какой-то
and it's not very secure.
заберет.
So if somebody breaks through the perimeter,
Была возможность
they should be able to steal the data.
по зашифровке.
So ideally, would love to be able to run analytics on top of encrypted data.
Их
And there are use cases like this. Big techs have been piloting some things like this.
аналитические данные просто по пользовательской базе.
Some analytical data across a user database, such as, say, user targeting.
Технология FHE, она позволяет
Take FHE, for example. This technology
выполнять какие-то программы на зашифрованных данных.
enables you to run software on top of encrypted data.
Лучше кинуть
Based on that, you can make a prediction about, what to advertise and to whom without really knowing who these people are.
на Западе по анализу
All this is currently being piloted in the West around, say, healthcare data. So you've got medical centers, you want to collect stats, but naturally, medical data is a particularly sensitive type of PII. So, within collaborations, they're using MPC or FHE in order to collect data and run their research on top of encrypted information.
лежат на столе сейчас.
So I think these cases are on the table right now, and we expect them to develop pretty quickly.
для этого сейчас начать.
On the tech side, what do you think we need to study now in order to be successful in the future? Say, I am a cryptographer already. What do I need to master now?
Фокусироваться на каком-то из
I think you need to focus on a particular stream. It could be zero knowledge,
блокчейнами.
and zero knowledge is
Zero Knowledge, они говорят, как классно, что появились
about blockchain, right?
кейсы.
Researchers in the zero knowledge worlds were delighted when blockchains emerged.
В основном история, которая вот присуща блокчейну. Вот есть FHE, Fully
FHE, fully homomorphic encryption.
про хранение данных на серверах.
which is about storage of data in a service so that this data is always encrypted and you can, process it at the same time for analytical purposes. Something that sounds somewhat utopian at this stage is doing the same with AI, so that you can upload your personal data to ChatGPT and it gives you recommendations while not really knowing anything about you as a person. Finally, MPC. The main use case for MPC is custodial wallets, where you need several stakeholders to perform any transaction. And this is something that's currently being used primarily by exchanges for obvious reasons. I mean, crypto exchanges, obviously. Well, traditional finance is sometimes using it, for example, in order books. That's it. Alexei?
Вопрос, какие интересные ты видел перспективы?
Let me remind you the question.
WEB3, и что для этого нужно делать, чтобы начать?
Promising cryptography cases, not necessarily in the world of Web3, and what does it require to jump on the bandwagon, so to speak? I am personally very interested in threshold cryptography, and I've explained why. So for threshold cryptography,
самое сложное это то, что у вас нету
and in some other fancy fields,
сколько хотите, где все красиво написано.
It's actually very difficult to find well-structured information.
Какой-нибудь лекторий МФТИ, очень много всего. А пороговый...
Well, you can learn lots of things about like blockchain, but in threshold cryptography, there are no courses, it's just articles. Gennaro,
статей на эту тему написал. Там вот...
He's published a couple of articles on threshold cryptography. Talks about key distribution mechanism. So he says that, we have this mechanism that we are using, but it's pretty lousy. I can predict the last bit with a probability of 3/4 rather than 1/2.
3/4, и это надо лишний раунд делать. Все пользуются...
But that will require another round. And most people are like, no, we don't really care about that. Then he publishes another article and says, you know what?
Угадать бит с вероятностью 3.
The previous method, where the last bit I could guess with a probability of 75%, it was actually better. And I spent quite a long time reading it all. So you cannot really predict which articles are good. And sometimes, if you don't know much about it, you're not really sure, if you gotta be reading this article and if you're gonna learn something useful or not.
Круто, да. Атака есть, но...
Ideally, you need somebody better than me explaining it all.
Еще не систематизировались, надо ждать.
So the problem in this field is that nobody so far has been able to systematize and order the data around. What kind of practices could be useful for a world like this or jobs like this? Writing books?
B2B сервисы, которые помогают тебе
Or
работать.
maybe, B2B services that could help you work, or data control services? Oh,
Если пробовать задавать чат-GPT какие-то, или там искусственному интеллекту математические вопросы, я видел, что...
have you tried asking math questions to ChatGPT or other GPTs? It will hallucinate a lot. No, but these are LLMs.
Задача чата GPT.
So, by definition, it's a large language model. So it will provide an answer which is sort of, by definition, is skewed towards user comfort rather than truthfulness. So what I'm trying to say is that AI is not really helping much. Like, we tend to believe LLMs too much.
2 минутки расскажу. Вот когда делали...
So let me take 2 minutes to explain why you want to learn cryptography. So when they, prepared the first remote voting in Russia, in Moscow in particular, they couldn't really use a long key. They used, a 256-bit key, and they did realize that it was not enough. And then they said, okay, we'll encrypt it 2 more times using the same key. And there was like even a competition. I think they offered a prize of 2 million rubles, or like $1 million. So the first cryptographer, a Frenchman who noticed that, very quickly snatched the prize. Every cryptographer should know that if you use the same encryption method twice, it will not be better. It's a little nuances, but they get you far. and combining these nuances,
какое-то плохое решение.
you can often have good cryptographic modules combined to lower the quality of security.
$2 миллиона.
Now, imagine you get $2 million now to launch a startup. What would you invest it in?
Денег такого бизнесового, тут, наверное, не ко мне вопрос, но вот мне прям...
I'm not a business guy. I am a big fan of threshold cryptography. It makes me tick as a mathematician.
Если DSA, это вот стандартная американская подпись.
Everybody is using, DSA6, the standard American one, but interestingly enough, it's difficult to share in threshold encryption, unlike Russian Ghost.
Я не знаю.
I'm not sure I would make money doing that, though.
Не было бы там.
So it could have easily been a great scientific study.
Распределенный, чтобы любой...
Well, I could have developed, say, a distributed signature so that, any person would be able to say, well, I've got this key, and, you would be able to split this key between different devices to ensure its safety.
А вы еще можете потом...
And what's great about it is that, this way you should be able to restore it if, for example, you lose your phone. Okay, sounds fun.
Сейчас Алексей у нас прям микрофон поднял.
Alexei is already reaching for the mic.
Хотел добавить в продолжение того, что Алексей говорил.
I just wanted to add here.
У них такой подход, как бы практически, но
I understand that you are very practically minded, Nick.
который тебе интересно строить.
But I think that it's only products that you are personally interested in that have a chance at succeeding. In the world of cryptography, where the amount of knowledge is colossal, a product which is just about chasing money is doomed to fail. Look at the founders of successful projects.
Этой темой заряжены и
they're all highly motivated. They're passionate about cryptography.
Продукт. То есть вот сейчас,
So what would you do?
тоже перестал в Сбербанке работать, скажем так.
Now, let's imagine that you start working for the bank or whatever. What would you do?
$100 ты взял.
Now, imagine you get $2 million. You have a team. What would you focus on?
с точки зрения перспективности или с точки зрения моих...
So are you asking me about my personal preferences or what I believe will be the future of the industry? Both answers will work.
Не очень большая конкуренция в области hardware.
I don't think there is a lot of competition now in the hardware market for cryptography. I see some big rounds there.
Hardware, это значит...
And what's the hardware there?
FPGA или там...
Well, FPGA, for example, or ASICs that are designed, sort of laser focused for specific cryptography.
Сервисные центры.
And the clients would be what? Protocols, public sector, or what? The clients would be the likes of Ethereum.
Или, например, там Big Tech, или...
Or the big techs, or crypto exchanges.
Я бы сказал...
There is a place and a role for cryptography.
Хотя это, конечно...
And I think that investors are proving that with their money. But please remember that investor money is not necessarily smart. We'll make sure to censor that out.
Какой-то интерес в этой области есть. Компании не...
But I am certainly seeing interest in this respect. Not too many players in this market, I personally think is quite promising. You wanted to say something else? I wanted to say that miners should be very interested in ASICs. Yes, but that would be a different subset of the market. So you mentioned hardware. Anything more, down to earth, something I would be able to do right now? Well, hardware is pretty down to earth.
Если мы берем каждую из этих областей криптографии,
And generally, in each of the areas of cryptography we've discussed,
как сказать, много...
you should be able to see lots of researchers
поэтому, в принципе,
pushing the boundaries.
можно встроиться. Можно...
So you should be able to enter any of these niches. It could be
Не так
FHE,
компаний, но есть, которые...
ZKVM.
результатов и...
Ты рассказал, что на
Not too many companies in the FHE world, and they're quite successful.
На FHE тоже есть, да.
There is demand for FHE, that's right.
Компания, они, по-моему...
There is a company called Zama. I think they recently raised $70 million. Yes, but they are working for WorldCoin, so that's like a captive project. No, they're not just serving WorldCoin. I think they're serving many other projects as well. So I think there are many niches out there. So it's all about having a good team and loving what you do. Russell, our favorite discussion. And what's the question again?
Вот ты пошел делать.
What would you invest in?
Я до этого, когда только задал, я подумал, я не знаю, как
My initial response
это как один
was ZKID wallet.
решение
Another answer is some privacy solution.
после, я не знаю, там торнадо кэш, всех этих случаев как раз таки
Because after Tornado Cash,
research немного приостановился, потому что люди боятся это.
research has slowed down.
И третье, возможно, что-нибудь такое вообще из продвинутой современной криптографии, из новых
And maybe something, in the world of advanced modern cryptography.
были не очень практичными и до сих пор остаются не такими.
There have been solutions that are not too practical,
Делать research
and, they still hold some promise.
или
So I'm talking here about obfuscation or witness encryption.
главный босс криптографии, через который в целом
If you like, that's the key boss or the chief boss of cryptography.
Просто делал ресерч, какие-то тулинги, продукты.
So what would you do?
про обфускацию.
Research or what? Well, in the world of advanced cryptography and obfuscation, I think I would do research first
Безопасно, более
to make it more secure and more practical.
можно вообще в принципе все что угодно делать. Можно,
And then
не знаю, любой протокол, где есть MPC,
we can grab any protocol that contains MPC with, its disadvantages such as requirements for liveness, for example.
на который
And then
программа с обфускацией и как бы все.
we can, just run a single node with obfuscation and replace so much stuff. Okay, Q&A time now.
Попрошу только сначала, ух ты, господи, чтобы вы говорили вопрос и чуть раз про себя говорили.
Please introduce yourselves before you're asking a question.
Вас послушать.
Thank you. It's been interesting to follow the discussion.
Видите ли вы какое-то направление совмещения
Do you see any way of combining steganography with cryptography?
как будто в вакууме, да, анонимное, но
Because this technology feels like anonymous in a vacuum, but then if you are
как бы правильно всё в курсе.
the only person logging onto a website at 4 o'clock in the morning, identifying you for who you are is not that difficult.
Сам факт этого использования. И второй вопрос еще такой. Есть ли какие-то менеджеры паролей тоже на Web3?
Are there, password managers running on Web3 that would be properly secured?
Ключ, но ничего не хранить.
Because I would love to have a key and avoid storing anything in my PC. Thank you.
Алексей или Алексей? Битва двух якадзун.
Я про пароли скажу. На самом деле вот в
Let
порогах
me answer about the passwords. In threshold mechanisms,
также
there is also a key generation algorithm. So yes, indeed, you can generate passwords in a distributed way,
генерировать. Так что это да, это есть.
and you can do it in a trustless way.
Не знаю.
I don't have an answer to the first question.
Человек проатаковал.
Первый чек в пуле торнадо кэш. Что ему делать?
Okay, so you are the first person in the tornado cash pool. I'm sorry, I cannot answer this question either. It's an interesting question for sure, but I don't know enough. My impression of password managers is that Web3 so far has not been able to add much to that.
Скорее,
But the show isn't over yet.
традиционные только работают. Ну, из того, что я видел.
That's my take, at least.
Я уже сейчас задам вопрос так.
Спасибо большое за дискуссию.
Thank you.
Вот у меня целый ряд вопросов,
I have a host of questions
подмечаний, я так сказал бы.
and observations.
Не новая история, она же с 80-х.
Threshold cryptography has been around since 1980s, right?
Что вы имели в виду, когда сказали, что это...
I wonder what you meant when you called it a novel idea.
Вот это первый вопрос, пожалуйста. Я не понял просто, о чем вы.
Ответ простой. Схема Шамира появилась в 80-х.
Well, the Shamira scheme did emerge in 1980, and that was indeed the first way of splitting it all. Then
Потом
Patterson developed an improvement in 1986. Signatures came around even later.
нарушителей, которые...
And, a production-ready way of splitting the key and refreshing it so that, the shared public key doesn't change. And then when you've identified the perps, how do you make sure that, there is some presumption of innocence in place? And then you also got to do your SIG. and it has to be fast and convenient. All this combination emerged very recently, but you're right. It dates back to 1980.
Именно в софте приложения вот, недавно начали
Okay, so you effectively meant that, the applications as we know them are indeed novel. So you said that encrypting, with the same tool set, so to speak, twice will not make things better, but that's not true. Take DES3, DES3, it actually works this way.
два алгоритма разных или один и тот же группу, то тогда станет, и там нужны дополнительные исследования.
So if the two algorithms you're using do not form a group, it will be better.
А Triple DES там K1, K2.
I'm sorry. Triple DES are K1, K2, and K1.
Нет.
Well, the keys must be independent. If they are independent, then you can do a classic man-in-the-middle attack. So in triple DES, it's not K1, K2, and K3. Two are equal, meaning that they're dependent.
Независимые, да.
That's exactly what I said.
А вот если AES зашифровать, там
What about AES?
группа или не группа? Вот тут мы вообще не можем.
Will AES be considered a group or not?
Так, человек
If you encrypt it twice with AES, it is prone to a classic MITM attack.
128, так осталось 20.
So the complexity remains the same, 2 to the power of 128. That's not true. I'm sorry, it is.
Не, я думаю, про это лучше.
I have a question. I suggest we have this debate off the stage.
Про full encryption, про аналитику. Вот, про
I have a question regarding full encryption.
какие реально
You've mentioned can be used for analytics purposes. What are the real-life cases you're thinking about? I've seen that, functions are very limited, like checking the median, but doing some proper analysis, not really.
Понятно, есть какие-то базовые статистические индикаторы, но в принципе
Well, they can certainly give you some basic stats indicators.
можно много
And they're now doing regressions, and with regressions, you can do a lot.
Любую можно делать, просто это упирается в...
I think you can do all types of analytics this way.
Да, на практике
It's ultimately a matter of computation.
показатели
Yes.
более простые.
So they are doing regressions already, meaning that all the simpler statistics can certainly be done.
Не оптимален сейчас FHE для AI. И
Can you please explain why FHE is suboptimal for AI and what kind of overheads it creates?
Это скорее к Лёше вопрос, что мы
The
говорим.
question goes to Alexei, in fact. We have said that FHE creates extra overheads for AI. Why is that?
В принципе, история, то есть на каждую, скажем так, базовую операцию есть достаточно большой.
So for every basic transaction, there will be a substantial overhead because you need to transform your polynomials.
Направление, которое называется bootstrapping, которое пытается
Now, bootstrapping is
более комплексные операции.
getting bigger now, where it tries to perform more complex operations.
Дорогая штука.
And still, inference takes time and is expensive, as long as we're talking about LLMs. Now, if you add FHE on top of that,
Не очень работает пока.
it will create substantial overheads.
Ждем прогресса.
So it's not really feasible. But we're waiting for progress here. Last question.
Все равно пойду отдам уже. Вот мне просто сказали, чтобы я выносил. Там вот.
То есть пока Николай идет, вот про AES, там с точки зрения трудоемкости я имел в виду.
The AES, and in terms of complexity. Okay, later on. Agreed.
Хотел спросить про гомоморфную криптографию.
I wanted to ask you about homomorphic cryptography.
Пожалуйста, более подробно рассказать, какие есть реальные...
Can you please tell us about real-life cases and which algorithms are being used now? And what are the prospects in this respect?
Ну, как я сказал, реальных кейсов их
Like I said,
много, но вот есть,
there are few real cases now.
мы говорили, есть еще, скажем так, прикольный кейс от Замы, это privacy.
Now, there is an interesting case with the Zama. It's a privacy DeFi where you can create hidden contracts and tokens on Ethereum.
Ну, они затащили гомоморфную криптографию туда, вот, и все.
And they did build homomorphic encryption into it.
Там перевод токена раз в
It
день.
does create overheads. In terms of gas consumption, it's like 10 times more expensive, but it gives you added privacy.
Осторожно, потому
But
что
then you gotta be careful with privacy, right?
а вернее, почти все правительства ее не любят, поэтому
Like most governments hate privacy,
кейс.
so you gotta be aware of the trade-off here.
Там нет,
Off-mic comment.
гомоморфная есть, ну, которую часть затащили
So there is a portion of it.
попроще.
No, I'm sorry. What you find on Solidity, I think, is not fully homomorphic.
То есть, я не знаю, какой...
Think about search engines.
Пишешь запрос какой-то, он выдает тебе ответ.
So imagine you're searching for something in Google.
FHE, ты можешь ему писать какой-то...
Now, if there is a server with FHE, you can send a request and it will return to you an answer without really knowing what your query was.
Большое количество use cases у FHE есть.
I can think of lots of use cases for FHE.
Не, оно действительно, я думаю, оно в перспективе огромное, но сейчас вот...
I think that the potential is there, and we're just scratching the surface at the moment.
Зала не будем, так у нас запись идет. Последний вопрос задаем, у нас минута осталась.
This is the last question.
Спасибо за панельную дискуссию такую.
Thank you for the panel discussion.
Каждым словом здесь
I subscribe to every statement you made.
ваше слово подтверждает вектор выбора того, чем я занимаюсь, моего стартапа.
And what you've said does confirm or does prove the validity of what my startup is doing.
Идентификация личности.
Now, we do believe there will be major issues with personal identification in the next 2 years. More than half of traffic now is bot traffic, and 1/3 of those bots are malicious and they break up registration forms.
В части
Right.
ZK, криптографии,
In terms of legalization of ZK cryptography in Russia,
ГОСТовская криптография России и
I understand that cryptography in Russia has to abide by GOST. And it's so difficult to introduce anything new because you have to get it through the Federal Security Bureau, you know, with the notable exception of Kuznechik.
Сколько времени процесс этот займет?
How long do you think this process is going to take?
Почему-то, мне кажется, Алексей ответит хорошо.
Да, это правда.
Somehow I know Alexei is best positioned to answer this question. That's correct.
Вы можете...
You know, if you want to apply it locally, you don't need to abide by GOST. I talked to a person at a central bank and said that, you know, the chips we are buying
низком уровне...
in order to use the signature there at a fundamental level.
Они говорят, если мы хотим быстро через Java
You know, it should be like DSA. So if we want to invoke it quickly through Java for signature purposes,
дадут сделать,
well, I mean, you won't be able to apply,
что нам делать?
you know, properly standardized system, but you can get the write-off, so to speak. You can get the green light from the authorities, particularly if you show that it's going to be helpful.
Усложнит процесс, но...
Now, it will be, you know, green light to a particular project within a pretty specific perimeter, though.
Наш, я не знаю, вечер или день криптографии, где как раз-таки, я не помню, спикер...
I remember a previous friends meeting where the speaker talked about implementation of MPC solutions in Russia and how difficult it is for him to go through all the, you know, legal
посмотреть, мне кажется, запись.
legal kind of loopholes, or I'm sorry, jump through legal hoops. Thank you very much, dear audience and our distinguished speakers. I invite you all to develop more great products, talk to our speakers, they know much more than they share. We also have lots of people and lots of great experts here, so let's develop great applications together. Applause to us all. Thank you.